So good afternoon all. So what we have last class we have seen about it. We have seen about the what is a robot, what is the actual definition of robot, why do we use robots, and what about the introductions, what are all the generations, what we have seen over on it, okay, and what are all the components, okay. So now today's class, what we are going to see it of Abina, we are going to see about what are all the basic components that we are seeing. So we are going to see in a detailed one, okay. So the first thing we all know that the first components of robot is required is about a controller. So controller in the sense we all know that what is the controller of the human being. So we all think that is to be the brain. Okay. Similarly, the controller will act as the brain of the robotic arm. Okay. And the controller, what does it do? It allows all the parts of the robots to operate together. Okay. So here the controller is the brain of the industrial robotic arm, and it will allow the parts of the robot to operate together. And apart from that, it works as a computer. It works as a computer, and it will allow the robot which will be connected to the other systems. Okay. And all the robotic arm controllers, so we know that it is to be all the activities which has been done by means of an program. So the robotic arm controller, which runs a set of instructions, so which everything will be written in code. So that is to be named as a program. Okay, so that will be given as an input. So we are naming as a teach is pendant. Okay, so the program will be inputted with a teach pendant over on it. Okay, and similarly, today's industrial robot arms, we know that it is use an interface that resembles or it is built on the Windows operating system. So the controller is the brain of the industrial robotic arm. So it will allow the parts of the robot. So it works as a computers and it will connect with other systems. So we'll have written in a code which is to be named as a program over on it. So the next, when we are saying about a robotic arm, we all know that it can able to vary in size and shapes. So we couldn't define in the constant position, okay, constant size or constant shape, whatever it may be. So I have shown the different varieties of industrial robot arms, okay. So the industrial robot arm, which is the part, there is a positions will have a end effector, okay. So in order to position the end effector, so what are all the things? It is we'll have a robot arm, shoulder, elbow, and a wrist, smooth twist and twist. So in order to position the end effector, so we'll be using all these components. Okay. So each of this joints, so what will happen? So it gives the robot for another degree of freedom over here. Okay. And so when we are saying about a simple robot with a 3 degrees of freedom, Abhina, there is a it can able to move in a 3 different ways. So we can have up and down, we'll have a left and right, or we have a forward and backward. Okay. So this degrees of freedom will determine what are all the things that we can able to have over on it. Okay. So in the case of we can go for 3, 4, 5. So in many industrial robots, we'll have a 6-axis robots over there. Okay. So this is to be first one to be the controller, which is act as a brain over on it. Second one, we'll have a variety in size and shapes, and we'll have a degree of freedoms over there. So simple robot will have a 3 degrees of freedom, which indicates the up and down, left and right, and forward and backward over there. The next components of robot are to be the end effector. Okay, so the end effector, which is connected to the robot's arm, and it will function as a hand. Okay, so what will happen? So this part comes in direct contact with the material the robot is manipulating. Okay, so some variants of an effector are will have a gripper, vacuum pump, magnets, and building charges. So these robots are capable of changing end effectors, and it can be programmed for different sets of tasks over on it. So we'll have a grippers and tools also there. Okay, so these are to be connected to the robot's arm, so which will be function as a hand over there. So we'll have a grippers and tools. So the end effector grippers, what will happen? This is the device which is attached to the robot's wrist to perform a specific task. So we'll have a mechanical grippers, suction cups or vacuum cups, magnetized grippers, hooks, scoops in order to carry the fluids over on it. Okay. So some of the grippers are shown over here. So we'll have a grip wire and release wire, so that it can able to hold the material, so it can able to handle the things. Okay. Next one, end effector tools. So when you are saying about the end effector tools, the device attached to the robot's wrist. Okay. Whereas in the case of, so the grippers also will be attached to robot wrist. So this also will be a robot's wrist to perform a specific task. So here we can do the task is spot welding gun, or we can go for arc welding tools. We have a spray painting gun, and similarly drilling spindle. We'll have a grinders, wire brushers, heating touches. Okay, so these are all the tools is available over in the case of an basic components of robots. The next thing, what we'll be requiring a drive. So the drive, we can define that it is the engine or the motor, okay, which moves the link into the designated position. Okay, so the links, when you are saying about the links, they are the sections between the joints. Okay, so usually we can go for any one of the. So what are all the availability drives, Abhina? We'll have a hydraulic, electric, or pneumatic. So this robotic arms can go any one of the following types of drives. So we can have a hydraulic or electric or a pneumatic. So what is hydraulic drive systems will do, Sabina? So it gives a robot with a great speed and the strength. And similarly, an electric system which is provides a robot with less speed and strength. Whereas in the case of a pneumatic drive systems, which is used for smaller robots, that is for the fewer axis of movement. Okay, so and the drive should be periodically inspected for wear and replaced if necessary overall. Okay, so this will be done overall. So we'll have a three different drives: hydraulic, electric motor, or pneumatic. So I have shown the difference over here, so this will be useful for your 2 marks. Okay, so whereas in the case of an hydraulic, we'll have a high strength and high speed. We can go for large robots, so it takes slow space, so we can have a mechanical simplicity and will be used for heavy payloads over there. Whereas in the case of an electric motor, a servo stepper motor, so it have a high accuracy and repeatability. We'll have a less flow space. We'll have a smaller units, quick assembly, and high cycle rates overall. So the next thing we have to see about the sensors. So we all know the sensors which has been second generation, which has evolved in second generation the year 1980. Okay. So what will happen sensors? So sensors is usually the sensor materials or sensor feedback. So it is used to, so the sensors will allow the industrial robotic arm in order to receive the feedback about its environment. Okay. And similarly, they can give a limited sense of sight and sound. So what the sensors will does it collects all the informations and it will be sending all the information, as electrically sending all the information to the robot control. Okay. So whereas this one of the sensors, so which is used to keep the two robots, so which work closely together from bumping into each other. Okay, and similarly the sensors can also assist and affect us by adjusting for variant part variances. And similarly, we'll have a vision sensors which is allows the pick and place robot to differentiate between the items to choose and items to ignore. So we'll have a different sensors. So we'll have a touch sensor, we'll have a force sensor, we'll have a contact sensor, we'll have a LED, we'll have a solar cells. So BSL sensors. So all these sensors, so generally what does it does, Adina? It will collect all the informations. That is, it sensors will collect all the informations. All the informations will send it to the electronically to the robot control. Okay. So similarly, so we know that we'll have a pick and place robot. So what sensors we have to use it? Vision sensors. So what does it do? So it has to differentiate the items. So it has to think of it, which has to be chosen, or we have to program which has to be chosen, which has to be ignored. So for this, what we'll be using? We'll be using of an vision sensor. So these are all the components which is required in the case of an robotics. Okay, so that is a controller. We'll have a controller. The next one, it will be varying in a size and shape over on it. And the third thing, we'll have an end effector. So end effector will be function as a hand. Okay. So we say that the end effector can be programmed for two different types of tasks. One to be the grippers and second one to be the tools. So grippers, so we can go for a hooks or we can go for a scoops. And similarly, we go for end effector tools. So we can go for arc welding, spray painting, drilling spindle, grinders, touches, so that we can turn. And similarly, the next one to be the drive. So drive, we know that it can be used for an engine or a motor. So we can go for hydraulic, electric, or pneumatic. Okay. So in order to, for smaller units, we'll go for pneumatic. For higher accuracy and repeatability, we'll go for electric motor. And for high strength and high speed, for usually for heavy payloads, we can go for hydraulic. And finally, the last one to be the sensors. So sensors, which is used to sense all the informations, and it will be sending to the robot controlled overall. Okay. The next class we can able to see about what are all the laws of robots available overall. Thank you all.